Hi Pre-Calculus Honors, so these are notes 3.4, and we are going to talk about properties of logarithmic functions. So the first thing I would like you to do is take a look at the calculator and think about any connections that you might see between those numbers, log 6, log 2, and log 3. Go ahead and pause the video and think about that. So hopefully you notice that log 6 log 2 plus log 3 is equal to log 6, and 2 times 3 is 6. Also, 6 divided by 2 is 3, and log 6 minus log 2 is log 3. And also, 6 divided by 3 is 2, and log 6 minus log 3 is log 2. So notice we could, let's take a look at our objectives, and then we'll talk about our properties. Number 1, we'll be able to understand the product rule, the quotient rule, and the power rule. Number 2, our objectives for today, be able to understand the change of base property. And number 3, be able to solve a logarithmic equation and consider the domain of the function. So again, hopefully we noticed that we have log of a times b equals log a plus log b, and log a divided by b is log a minus log b. So go ahead and let's look at the calculator again. So again, notice that we have log of 2 plus log of 3 is log of 6, while 2 times 3 is 6, and log 6 minus log 2 is log 3, which is 6 divided by 2. Okay, wonderful. All right, so what we're going to do now, we're going to go ahead and prove the product rule. So we're going to start by saying let's let x equal log base b of r, and let's let y equal log base b of s. So now we can use the definition of logarithms that says that b to the y equals s and b to the x equals r. Okay. So again, we use the when we're proving the log the product rule, we just have to make sure we don't use the product rule in the proof. So now what we're going to do is start with one side of the equation. I like to start with the left side of the equation. Okay, and our proof will be done when the left side is equal to the right side. So we know that log base b, notice r is b to the x and s is b to the y. And then again, we know that when you multiply two powers with the same base, you add the exponents. Okay, and now we could use the power rule, which says you can multiply x, the quantity x plus y, times log base b of b. And now we'll use the change of base property that says that log base b of b is log b divided by log b, which is 1. So we end up with x plus y, which we know is log base b of r plus log base b of s. And so we are done with our proof. Okay, so again, here are our properties. Product rule, quotient rule, power rule. Okay, so let's go ahead and do some practice problems. So for the first problem, for number 3 I should say, we're going to go ahead and rewrite this using a's, b's, and constants. Okay, so the first thing you should do before you get started is realize that log of 10 is 1, because if I don't put a base there, the base is 10. So when I'm thinking about 30, I want to think of how could you use 2's, 3's, and 10's. So I could say that's 3 times 10. And we know that the product rule says that that's log 3 plus log 10. And we know that log 10 is 1 and log 3 is b. So again, b plus 1 would be our answer. Go ahead and pause the video and try parts b and c. So again, your answer at the very end, notice you should have constants or an a or b. Okay, so notice you have log of 0.8. So you could say that's log of 8 divided by 10, which is 2 to the third divided by 10. Now the quotient rule says that's log 2 to the third minus log of 10. And so we have the power rule that says you can write log of 2 to the third as 3 log 2. And we have 3 log 2 minus log 10. So again, log 2 is a, so we have 3a, and log 10 is 1. For part C, you could write log of 9 divided by 2. So that's log of 3 squared divided by 2, which is log 3 squared. Quotient rule, it says minus log 2. Power rule says you can write that as 2 log 3 minus log 2. So we have 2b minus a. So again, 2b minus a, since log of 3 was b, and log of 2 is a. All right, so what we're going to do now is we are going to write this logarithm for number 4 as separate logs of single arguments, and then in parts 5 and 6 we're going to go the other way, and we are going to write a single argument, a log of a single argument instead of separate logs. So for the first one, what I want you to think about is when you're multiplying the argument, notice it inside the parentheses there, when you're multiplying, you're really adding. So we have log a to the third plus log b squared. And when you're dividing, you are really subtracting. So that's log of c to the 1/3 power. Because again, the cubed root of c is c to the 1/3. Okay, now again, you can use the power rule. So that's 3 log a plus 2 log b minus 1/3 log c. Okay, so you wrote separate logs with single arguments. So what we're going to do now is, notice we have separate logs, so we want to have a log of one argument. So let's clean this up a little bit. I think it's easier to manipulate the logarithms if you go ahead and put the 2 with the d. So again, that's the power rule. Log d squared. Right, we can write log d squared instead of minus 2 log d. So now, notice when you're subtracting, you're dividing. So anything that comes after a negative sign, that is going to go in the denominator. And I'm sorry, make sure you fix it. That's a plus log c. So the c is going to go in the numerator because that's after a positive sign. And then anything after a negative sign, notice that would have to go in the denominator. So we wrote that as a single log of a single argument. Now, for the next part, I think you might want to clean that up a little bit. First of all, you have to have the same base. I'm sorry, yes, the same base. So notice you do, because all of these different, notice we have these different terms, and they have log base 2. The first thing we do is we distribute the negative 2. And so we have negative 6 log base 2 of y plus 2 log base 2 of z cubed. So now what we want to do is, I know the power rule, you can write this as 6 log base 2 of y, or you could write this as minus log base 2 y to the 6th. Notice when you go ahead and you want to, I guess we're using the power rule where instead of putting the 2 or the 3 in front of the log, we are going to go ahead and put the 2 as an exponent, but notice there's already a 3 there, so you'll have to multiply. So we have plus log base 2 of z to the 6th, because 2 times 3 is 6, minus log base 2 of x. Okay, so now we're going to write this as a single log of a single argument. So we can combine, we can go ahead and use the power rule and I should say the product rule and the quotient rule, because the bases are all 2. So again, anything after a negative sign, you're subtracting. So y to the 6th goes in the denominator, the x goes in the denominator, x to the 3rd, and z to the 6th, you're multiplying. So that would go in the numerator. So now we can just simplify. We have log base 2 of x squared, z to the 6th divided by y to the 6th. Okay, let's look at the next example. And again, just remember the change of base formula. You can choose any base you want. If you have log base b of x, you can write log of x divided by log of b. Again, people typically choose 10 or e. But for this question, they want us to write this as a natural log. So you could say log x plus y divided by log of 1/3, and then again, choose any base you want. We're going to choose e, so you can say natural log of the quantity x plus y is equal to the natural log of 1/3. We had a base of 1/3, and now we have natural log. Okay, so let's think about this one. It says, what transformations would transform y1 into y2? Now the problem is it's very difficult to compare two things that are not similar. Okay, notice we have, for the first one, actually, we have log base 10, and for the second one, we have log base 10. So if we think about y2, isn't that log x plus log 10? Because again, we're using the product rule. And again, since the base is 10, log base 10 of 10, that's 1. So we have y2 is log of x plus 1. So the transformation would be up 1. Go ahead and pause the video and think about how you would consider the transformations from y1 to y2 for part B. Now, for y1, notice the base is 10. For y2, the base is 2. Again, very difficult to compare two things that are not alike. So we're going to use the change of base property. So we have log x divided by log 2. And so 1 divided by log 2 times log x. So this is actually a vertical stretch or a vertical shrink. So we have to think for a minute. Is 1 over log 2, would that be a stretch or would that be a shrink? Pause the video and think about that. Log 2 is actually approximately 0.3, so 1 over log 2 is a number greater than 1, so this is a vertical stretch. Now, if this was on a test or a quiz and we didn't have a calculator, I don't think I would take points off if you said shrink. It is a vertical stretch, but again, you could think of this because notice that if you have log base 10 of 2, you would say 10 to the a equals 2, and a would have to be a number that is not greater than 1 to make this true. So that's how I know it's a vertical stretch. And about a 1 over log 2, which is actually just a number. It's a constant. For the next problem, we're going to try and think about how you would transform natural log of x into the following graph. So it's very difficult to compare two things that aren't alike. So let's take f of x and use the change of base property. So we have log of x over log of 4, and we changed it to a base of e. So we have natural log of x over natural log of 4. And now we would like to compare it to our parent function. So our parent function, natural log of x, this would be a 1 over natural log of 4. So you'd have to think, to decide if this was a vertical stretch or shrink, you'd have to try and figure out, is natural log of 4, is that a number between 0 and 1, or is that a number greater than 1? And notice natural log of 4 is log base e of 4. Call that a. E to the a equals 4. So I know that, I do know that a would have to be a number that is larger than 1. So I know that 1 over natural log of 4 is approximately 0.7. But if you did not have a calculator, I don't think I would mark that wrong on a test. But that is a vertical shrink by a factor of 1 over natural log of 4. We'll go ahead and pause the video and give number 40 a try. I know that natural log of 7 is a number larger than 1 because natural log of 7 is log base e of 7. I called that a. E to the a is 7. A would have to be a number larger than 1. So 1 over natural log of 7, that would be a vertical shrink. Okay, let's take a look at the next two problems. These are actually homework problems. I will actually do 73, and then I'll give you a little time to do 74. So the question is, what is the transformation that will take you from f of x to g of x? And the problem is, it's very difficult to compare two things that aren't alike. So what we're going to do is we're going to find the inverse for each function and compare the inverses. So we'll switch the x's and the y's. Natural log is log base e. So notice that for their inverses, you have a reflection over the y-axis. So that means that for f of x and g of x, the inverse of e to the x and e to the negative x, you must be reflecting over the x-axis, because you're switching the x's and the y's. Go ahead and pause the video and try number 74. Inverse of log base 10 of x is 10 to the x, and the inverse of log base 1/10 of x is y equals 10 to the negative x. So that is a reflection over the y-axis. So for f of x and g of x, that must be a reflection over the x-axis. The next thing I'd like you to do is think about problem number 9. So if I asked you, are the graphs of these two logarithmic functions the same? What would you say? So go ahead and pause the video and think about it. would these two graphs look the same? And then go ahead and graph them on your calculator and see if they are identical. Okay, so let's look at y2 first. 2 log of x. So here's the graph, and I think we were expecting something like that because we know that x has to be greater than 0. Because of the very definition of logarithms. Let's take a look at y1. So I will turn that one on. Here goes. So we'll graph y1 and then we'll graph y2 right on top of it. So if you take a look, there's y1. Notice that y1 looks different than y2. And if you compare their domains, notice for y1, if you had a negative number, a negative value for x, and you squared it, now it would be positive. So the domain for y1 is x can't be 0, and the domain for y2 is x has to be greater than 0. So that's why the graphs are not identical. So yes, you could use the power rule, but the original function would dictate the domain of the function, and y1 and y2 have different domains. Why don't we take a look at number 10, and we'll practice solving. Go ahead and pause the video and solve 10a. So before you solve, you might want to consider the domain. For 10a, the x can't be 0, but x can be positive or negative. So when you say x squared, right, so 10 squared equals x squared, we have plus or minus 10. When you try part B, you might want to also consider the domain of the function. Go ahead and pause the video. You can multiply both sides of the equation by negative. So we have 10 to the negative 2 equals x squared. So the answer, is it 1/10? Is it negative 1/10? Or is it plus or minus 1/10? Go ahead and pause the video and consider the solution. Two answers because the domain is x can't be 0. So we could have positive 1/10 or negative 1/10. The last 4 questions, I'm going to have you grab your calculator, and we're just going to practice graphing on our calculator. So if you use the change of base property, you could say the log of 17 divided by the log of 2 is x. Be careful with your parentheses because a lot of the calculators will give you a parenthesis. Make sure you finish that before you divide. And you should get 4.087. Now for part B, you have x to the 3/5 equals 7. So how would you get x to the 1? Go ahead and pause the video and think about how you would make that 3/5 and x to the 1. If you take both sides of the equation to the 5/3 power, now you have x to the 1 equals 7 to the 5/3. You could use a calculator and you would get 25.615. Go ahead and pause the video and try part C. You can divide by 2 and then change this to log form. So we would have log of 4.5 divided by log 3, and then you would have, I would go ahead and divide that by 5 or multiply by 1/5 to find x. Type it into your calculator. You should get 0.274. Okay, so for the last problem, you have a choice. I believe in class we graphed one of these. Okay, graphing is a great way to solve it. You should end up with negative 0.46. So go ahead and try the graphing method on your calculator. Pause the video. Okay, so now I wanted to show you an algebraic method. If you wanted to, you could take the log of both sides of the equation. And now you could use the product rule. Don't forget to put x minus 1 in parentheses. You have the quantity x minus 1. So notice that log 2 and log 3, they're just a number. So you can distribute. You could have x log 2 minus log 2 equals 2x log 3. And let's get every term with an x on one side of the equation and the terms that don't have an x on the other side of the equation. And so we can factor out an x. So now if we divide log of 2 by log 2 minus 2 log 3, and again, make sure you put that whole thing in parentheses, you can get the answer, which is negative 0.46. So again, you might want to practice doing this both ways. Those were notes 3.4. Great job, everybody.